Hello there, my name is Jacques Troussard and I welcome you to my second game programming screencast for Computer Science 440. In this video I will be walking through my code, covering key aspects, and finally demonstrating the game. The assignment for this week was to program a version of the game Concentration. In this game, the player is tasked with discovering pairs of patterns until all pairs have been found. Each turn is comprised of 2 guesses. If the player makes a match, the pattern remains faced up, signifying their status. However, if the patterns chosen do not match, then the guess patterns are covered again after a brief pause. In this version of the game, there will be 12 pairs to match. The player will also have as much time as they like, yet we will be recording and displaying the time that has passed. Now, without further ado, let's move into the first part of this video where I will be covering the program structure. Okay, well, let's just dive in, take a look at the game, or the project structure. There's 3 parts here, pattern, logic, and game, but essentially there's only 2 parts. There's the graphical part, which game CPP, pattern CPP, and its associated header file are tasked with taking care of. And then the mechanics of the game, which is handled by logic CPP and its associated header file. So I will go into greater detail on how these all work together. But the last part of the structure would be this resource file here. So within the file structure, the actual file structure, there's a folder that I named assets, and then I've tucked this asset in there, which is the scoreboard font. That, in short, explains the structure of the project. And now we're going to move on and get started into the nitty and gritty and how the game works. Okay, so thank you for bearing with me going through the header files. Let's get on to something a little bit more fun and interesting. So let's get the header comments out of the way. Here are all the includes, input-output stream. The allegro includes here, main library, native dialog boxes, primitives, naturally, font, and the TFF. And then we have to link in our 2 files here, logic and pattern. For this assignment, we were graciously allowed 2 global variables, so I took full advantage of that. That's mouse position X and mouse position Y. Some function declarations follow that. Drawing the board, I think that's pretty self-explanatory. These 2 are I'd say the heart of the game. You can see they do a lot of heavy lifting with all the arguments that they take. A board click is really just picking up the graphical position of the mouse, and then it's sucking in a lot of data, which it doesn't really use itself, but it passes down into further functions, such as square click, which is I'd say the most important function of the game. So once the board is clicked and this position is realized, the status of the game is passed through. The square click triggers a bunch of stuff if that square is playable, and passes down more information, and then it doesn't really do too much if it is not playable, which is natural. It's not hard to believe. Next function, draw pattern, pretty self-explanatory. Now, these next 2, I probably could have named these a little bit better, but when the game was done, Microsoft Visual Studio doesn't really have a great built-in refactoring command. I looked, you have to download some stuff, and I just didn't have the time to look into research it. So no refactoring with Visual Studio built in. Kind of annoying. So I kind of just stuck with these names. So flip and flip all. The reason I used these names was because I was thinking of this game as if I were playing it with like traditional playing cards. So I'm flipping the card, it's been revealed to me, and I'm flipping it back. So this is to hide the pattern. And this is a helper function for resetting the game if the game game is over and the player wants to play another round. So it just covers everything. Draw info. So this is just updating the status of the game as far as the player is concerned. So game time, their current score, and then it needs that font resource to print it nicely. Alright, so those are the function declarations. Let's look at main. Alright, so things are getting a little bit more interesting. We are moving into the main function. These are my variable declarations. So we're creating the game logic here so we can access the variables and functions. These two variables are used for the time calculations. I'll go into more detail when we reach the actual function for that. Here are my variables which are initialized. We got two flags here, done, which represents the entirety of the game. So actually shutting down the program, not so much that the round has been won. This is a draw variable, draw flag, used to obviously draw the patterns when they need to be drawn. Two more time variables associated with calculating the time. Again, I will go into further detail when I reach that function, when we reach that function. Here, I'd like to explain this because I've been doing it in my labs as well. I'm tying in my French class with my programming class. So I just sneak in a couple of French words in here. This is window width and window height. So largeur fenêtre and hauteur fenêtre. They have been set to 640. I'll go over that real quickly. I felt that I didn't want to really get bogged down or concern myself too much with the primitives of this game. I was of course interested in making it aesthetically pleasing, but after all the labs that we did and how much time was being spent into making these like kind of fancy drawings, I felt that every opportunity that I could take advantage to really minimize the amount of time I was going to be spending on this kind of not so important part of the game, I was going to take advantage of it. So that means perfect square. 640 by 640, no rectangles, whatever, just made all the math a heck of a lot easier. These are pretty self-explanatory too, so these are just counters. The score, so how many pairs have been made, and the guess counter, which maxes out at 2 and is used as a flag or a control to jump out of loops. Alright, allegro variables, again a little bit of French here, fenêtre for window or display, and the event queue. So those are pretty standard. And here are my initializations and my kind of error checking. I did want to, before I kind of zoom through these, I wanted to add something that I found in a forum while I was trying to solve kind of, not really a problem, but a little annoyance I had. That was when one of these native boxes popped up, I was getting the noise, or they were getting triggered. They weren't popping up. So they were getting triggered, I would get the noise, and then I'd have to kind of shuffle through all the windows that were open and get the message box which popped up all the way on the bottom. That's what happens if you put null. If you put in this function here, al get current display as the first parameter, it brings it right on top of the game display. So that just saved a little bit of time and made things a little bit less annoying. So, okay, so zooming through. Main library, creating the display, or initializing the display, initializing the event queue, and again, all of these return -1 if they're triggered, which exits the program. Installation of the keyboard, just to register that escape key. This was more for me than the player. Jumping back and forth while debugging, just easier to hit that escape key than fumbling around for the X. The mouse, now here obviously this is pretty important for the game and to the player, so we install the mouse. And here are the add-ons. I'm not sure, I was trying to do checks with them and was running into kind of strange errors. probably could have researched it some more, but was kind of pressed for time on this. This was a little bit bigger than it took a little bit more time than I thought, this entire program. So I have seen examples given in labs and such where these are not checked; they're just kind of thrown in. So that's what I did. Just kind of threw them in and trusted that these add-ons would are being called successfully. Now that the font add-on has been made, I create that pointer to the font called details. And now we're getting into the heart of the game. So this is the first important, or the first kind of fun function call. Alright, so here we are, looking at the setup function as part of the logic module here. I got to go over kind of a disclaimer here. As you can see, this is heavily commented. This is done on purpose because we were suggested, as part of the kind of the assignment instructions, it was suggested to us that we make a couple of different functions to do the job that this one function is doing here. And when I thought of my implementation and started coding it, it just seemed a little redundant to split it up into several functions. And it worked so well together as one. I mean, you can see here, you know, we got maybe 5 or 6 here, you know, maybe 12 lines, another 20, so maybe like 30 or 35 lines of code. It just didn't make a lot of sense for me to split it up, and it worked so well together. So I guess you could say I overcompensated by, you know, very carefully and thoroughly commenting this function. That's my disclaimer. Now, kind of like another caveat that I need to go into is to introduce the pattern identification scheme that I decided to use, because that makes it's pretty important to understand what's going on with the setup. So each of the 12 unique patterns is given a unique identifier, and here I've decided to use capital letters A through L. I get you your 12 unique ones. Also, the board values will be identified with a couple other capital letters. Z, for instance, is going to represent that unusable bottom right hand square, where the status of the game, the time and score, is going to be displayed. And there's a few other ones here that are going to be used during the game, which is O and X. These do not correspond with any of the pattern ones, but they will identify a playable square and a matched square. And there's also another one that I'll go into further down the line, which is T, which is to represent that the square is temporarily being held because it's a guess, and we're in the process of completing the turn. So now that you have a good idea of what I'm using, what kind of scheme I'm using, what kind of primary keys I'm giving to the values of the two-dimensional arrays, we can get into how they get loaded. So the game is played on 2 boards. One, which acts as a master copy. It's kind of a constant. Nothing doesn't ever change in here. It just simply gets loaded in the beginning of the game with these identifiers randomly positioned within the 5x5 board. This guest board is the one that the player is going to be interacting with, so it's going to identify playable squares, non-playable squares, squares that have been guessed, and squares which have been matched. To facilitate the initial loading of the game board, so the constant of the main board, I'm using this single-dimensional array called pattern on deck. Pattern on deck is what is going to eventually feed this board, and it's going to do it in order because I'm going to randomly load it. I'm going to randomize the loading order of its indexes. So I'm going to load, say, I'm going to grab A from here. This is the dictionary, sort of all the possible IDs of the pattern. So I'm going to take A and then randomly choose an index and load it into the pattern on deck array. Once this is full, and its size is 24, so once all of its positions are full, it's just going to in order load into game board. But since these have been randomly selected, there's no need to randomize this 2D. So this is a lot easier to randomize than a 2D board, right? And probably a lot less loops involved as well. So to begin, this pattern on deck is randomized with initialized with Y's in every position, so that I don't really like using nulls. Try to avoid that when possible, especially in C++. So let's get started, right? We're going to seed my random generator is seeded with time. This load sequence is just a simple counter for this while loop. It's a flag for this while loop, which allows for each half of the pairs to be loaded. So the first time we go through this for loop, it's going to be installing only one half of the pairs, and then the second time it'll be installing the second half of the pairs. So this is kind of an intuitive way to prevent doubles and to separate the loadings. So the loading happens by this for loop. This is the number 12, the 12 unique IDs. So for each ID, we're going to go in and grab one. So we start with position 0, which grabs the A. We generate a random index number, which is modded by 24, and that's our control, so that we're not receiving an index number that is just out in memory and not part of the index. That's the my size control for the array. Before we plug it in, we got to see what's going on with that position in the array pattern on deck. So if it doesn't equal y, that means that something's already been placed there. So let's just increment it. So we're going to do kind of like a linear probing to find the next open position. So if that random number is not at the very last position, so we don't want to increment it off into random memory, we want it to stay in the array, we're going to set the array index to -1 and then immediately increment it. So it's going to be set to 0, and it's going to, so that finishes this suite and comes back into the while loop and then checks it. Hey, is 0 y? And if not, let's just say there's something in there. It's going to check if it's the last position, which it's not. And so it doesn't get set to -1. So then it just jumps down here and it increments it. So then it would be at index position 1. So let's just go back up here, and the index position 1 does contain the value y, so you would break out of this while loop. Then here is where we're actually setting that value to. So index position 1 would have been set to A. In fact, that can never happen because A will always meet a y in pattern on deck because nothing is in there at that point. Alright, so it goes through the for loop 12 times, and so even if it runs into hundreds of collisions, eventually it will fill, and once it's full, excuse me, what I meant to say is that this for loop doesn't increment into the next unique identifier until it has found a spot. So once it's found its spot, then it can go on into it increments the I here. Once it breaks out of this for loop, we increment the load sequence. So now we're on load sequence number 1. Well, we were on 0, now we're on 1. It doesn't equal 2, so we're going to go through this whole process one more time. And then pattern on deck should then be full. So every one of its indexes will be full, and we break out of this part of the game. and there we have it. We'll have a random board. Uh, let's see here now. I'm sorry, no, the pattern on deck is done. Now we're going to actually load it into the board. This is pretty simple. So we're just going to count, our on how many units or how many identifiers we're getting out of the on deck counter, and just go into a simple for loop. It's double nested, so that we can go each cell in the the 2D array. So we just go, okay, so for row 1, column 1, well, excuse me, row 0, column 0, just go ahead and put the first or the index 0 on pattern on deck. We do all this again in order because it's already been randomized by this procedure here. We increment it, we go on to the next one. Now we have to load the guest board. Is much like this operation. There's no randomizing going on because the player is going to be interacting with it. We need to set every single one of the positions as playable, save for the detail one, which I'm going to set to X, which means that it's played, but it doesn't matter. So it just needs to always be set to X so that the player, when it's clicked on, it thinks that the board's engaged, or that position is engaged, which it actually is. Alright, so our setup is done. So let's see, what's after that? We're registering our event sources. Pretty straightforward. Display, a keyboard, and the mouse. Then we prep the display before the game starts, so we're clearing to black and then giving it a good old-fashioned flip. These variables are just kind of temporarily holding the mouse position when guesses are made. So you can see it's X cover 1. So this gets called to a covering function if there's a mismatch. Just to remember, hey, go back and cover guess 1 and then guess 2. So let's start the game loop. While the game isn't done, let's draw some things to the board, right? So we're going to draw the details, draw the board, and then give it a flip. Let's take a look at this one, right? So draw board. Again, I was really trying to save time with the primitives here, keeping everything easily divisible and square, so on and so forth. So this is just a bunch of lines. So each direction required 6 lines. This is the very top. This is the very bottom. So here are our horizontal lines from 0, 0 to the other end of the display. Draw a line that's 2 units thick. That just it's incrementing each row 128 because that's 640 divided by 5. So we start at 0, 128, 256, so on and forth. So we draw all the horizontal lines. This logic is repeated, but just done vertically. So the number which gets incremented are the X values here. While we're talking about drawing, let's take a look at the draw info. So this would be the very bottom right square. It gets reset every time. So I draw a black square over its location, save a few pixels here so that it doesn't cover the lines. I don't know if I need to worry about that because this gets called before the lines do. So then the lines would cover that black box. But I guess it's still good to be mindful of the fact that you don't want to cover the lines. So black it out, flip it, and then let's put our information on there. So the time goes first, go into how this gets calculated. And then underneath, I just have a title saying score, and then below that, just a fraction showing that your score is simply how many matches you've made out of how many matches remain. Okay, so we've drawn the board, we've gotten the game details drawn and set up. This is the next step in this while loop here is just to check to see if the game is over or not. And I've done it in that order so that the score and the time are updated one last time before the game registers whether it's done or not. So, because if this came after, it wasn't registering that last match. So it was 11 out of 12, and then the game would end. So, not the program, just that round. So, for this, I decided to have a box actually pop up. So this native message box pops in front, as I explained earlier what this does. Gives you congratulations, yada yada yada. But the type of box, instead, I found that there's this one called yes and no. So you can receive feedback from the user this way, and it's returned as an integer. So this was all readily available on the documentation for the website. So the native box here, just kind of read down, and this is the yes and no. So, and right here, it's explaining the returns. So the returns come in as a 0 if the window was closed without activating a button. So obviously that being Alt F4 or the X. It's a 1 if OK or yes were pressed, and it's a 2 if cancel or no was pressed. So if the reply is 1, the player wishes to play another round. So we're going to reset the board. And here's what I was saying about that durability, or the single function of this setup here. It easily works as resetting the board as well. So we just call it again within this while loop. It randomizes each time it's called, so no worries there. The this show guest board is, oh, you know, this is a this is a debugging line I forgot to get rid of. So what happens here is this just simply prints, that's down here, show guest board. So it's just a simple for loop that prints to console the status of the guest board. So it just prints so space here for every row, and then for each column or each cell we'll print out its value and a little separator bar here, so the guest board. So what the expectation of that is that once the board is set up, the game board, which is the one the player's interacting with, we should see all zeros except for the very last bottom right, which would have an X, because that is as we already went through that process here, it's set as an X right here. So it just does this, it confirms, you can visually confirm that this happened as it should. So I think while I was developing, I think I hard-coded the printing of the master board to see that the randomization has taken place. So let's get rid of that. And then flip all, as I mentioned before, this just blackens the board because the graphical part of the board isn't being reset with this. This is logic. It only takes care of what's happening behind the scenes. So the matches that you've made from the previous game are still sitting on top of the board. So we put black boxes over the whole thing, and that graphically resets the board. So as the player understands, they're playing on a new board. And then these are just the details of the game, kind of trivial things, but just resetting the score, resetting the time, and then this flip flag. And then, notifying this if statement, not activating this if statement anymore because the board being finished is set to false. Now, if their selection was not a 1 and it was either a 0 or a 2, we just set the highest level flag to true, which is the done variable. This one exits the entire program. Because I'm not counting down, I'm counting up. So I'm taking the difference between the times and adding it to this kind of, I mean, it's not officially a static variable, but like in practice it kind of is. It's just being continually updated and added to it. And this is what's being displayed to the player. Difference in time is just the little increment that's being added to it. It's not very interesting. So the events, these were fun, mostly because at the end I was struggling with the clock, stuttering. It appeared to be stuttering. It wasn't stuttering, but the problem was that kind of like the linear progression of the program was coming down game CPP and then hanging up right here, and it wouldn't move. It wouldn't allow the program to progress unless the mouse is being moved on the actual display. If you just left your mouse there and let's say you were thinking, the time would appear to be frozen, but it was actually still being checked. The screen wasn't, the graphical part of the screen wasn't being updated because it wasn't progressing past this to touch one of the flip commands. So time moves on, right? But it's game time wasn't being updated and printed to the screen because it was actually waiting for the event. So I felt like this probably should have been more explicitly communicated to us, that this was the event capturing function that we should have used. I might have missed it in one of the notes or the videos, but I think I watched them all. I think I read everything, but this is the one that seemed to get it working for me. So instead of allegro wait for next event, you're saying just get the next event. So I tried a whole bunch of things about like using if statements, trying to see if the trying to work with like an empty event queue and to pass through and whatever. So but this so I'm kind of revealing some of my ignorance here, but when I read about this, it sounded like it's what I needed, so I used it and everything worked, so I'm happy. So this has been, personally, this is recorded to be as in this allows the progression of the program to pass through if there are new events, and the other one is explicitly holding the progression of the program and waiting for that next event. So that's a useful distinction to make, and I imagine it will be pretty important moving forward in this class. Okay, so we've seen these before. X out the window, escape key, and here's the mouse. Our global variables are being set here, and they're being pushed through, or I'm sorry, they're being passed through this board click. So this is another one of the more interesting functions. This is a game function. So we can scroll down here and take a look. A whole bunch of other stuff is being passed through, like I said from before, because these may or may not need to be useful. The first step of this game is to find out where the mouse had clicked, and then whether it was a useful position to click, and then it was going to require this information to trigger events or process that click. But we didn't know whether we need these or not until we get further down into the logic of the game. So for a relatively especially this board click, relatively simple function, it looks like it's doing a whole bunch of work, but really it's just playing a game of programming telephone where it's just passing this information along in the case it's necessary. So that was a little bit long-winded. Let's move on, right? So this is just a translation type of function. It's making an like a translation of the mouse position graphically, which is not quite array positions yet, but it will get translated that way. So its graphical measurements can change, but the idea is that there will always be these 5 if statements that are necessary, because the game will have the 5 blocks. So you could theoretically make this a huge board that takes up a huge screen, or a smaller one fit for a phone. You would change these measurements, but the row is still the same. So that logic, that implementation stays the same. This information, if necessary, gets passed into logic. Now these drawing are more directly related to game. So this is identifying the center y-axis position of the potential square. So of this row, so we're saying, hey, the player has clicked, their y value of the mouse is less than 128. That means they haven't brought the mouse down very far. So they're in the first row. So we know that when we want to reveal one of the patterns, that its y-axis, at least the information we're going to pass to pattern, to help it understand where the center of the square is 64. It's half of 128. We know that that's the furthest down we can go. Now, this just repeats itself, but again, it's just incrementing it by 64, because by 128, because every row is 128 pixels deep. I guess we could use the word deep, right? Or tall. So we have 128, 64 would be the middle. Then we have another 128 pixels, and then 192 would be the middle of this row. So, so that handles it horizontally, and the vertical nature, or the vertical nature of the position, is handled by this bank of if-else statements. So effectively, the same kind of ideas being played through here. The kind of more logical representation of the position is being set, and then its x-axis based center is being set, and again incremented by 128 each time. Alright, once these have been identified, we're going to, whether the square is playable or not, we're going to record this. I guess this could have been pushed down further, but I don't know. It just looked like it was the next thing. Like, hey, let's figure out what guess this is. This guess counter, if it turns out to be a non-clickable square, it just gets canceled further down. But so we're setting these. These are representing these covering ones. So in case it doesn't work out, I want you to cover these positions. I got tired of writing that out, and just to make the distinction that these are not being passed through. These are just being kind of oh wait, they are being passed through. I'm sorry. Yeah, it's just time saving. X C1, so X cover 1, Y cover 1, X cover 2, Y cover 2. Okay, so all that's done. Now let's see if all that work was worth anything, right? So let's see what happens with that particular squares clicked. Carries out natural operations on square click if playable. So there's a logic function called isPlayable. It gets these logical representations, so the row and column numbers, and we make sure that draw has been set to true. So let's go take a look at that. This, I believe, is a pretty straightforward function. Checks the status of the square. Now the status to me as a developer is one of the four. I wrote down these just to help me while I was kind of making my way through the program. The square is either clickable, so it's a dark square that can be revealed, or it's either been guessed, which means it's revealed to the player already and nothing should happen. And the third is that it's matched, so it's revealed, but it won't be hidden ever again. And the last one is that it's the detail square, which, we've gone over that many times already. So to have the row and column numbers match up, so this is just me coding at different times of the day, and I had to just make this adjustment. So previously here, the first row I indicated as 1, should have been the 0, but so I just make that correction here, and a simple check of the board. So, hey, at this position on the guest board, do we have a 0? If it's a 0, if it's an O, that means we're playable, so we're going to return true. If we have a T, we're going to return false. Now here I have the comments here. It kind of goes into why I separate here. This returns a Boolean, but I wanted the distinction because I had previously some debugging print statements here, so I could see what was being returned by this is playable, just to double check and make sure. So that's why you have this kind of strange else. Really all I need is this, but I kept this here just to as a monument or kind of an indicator that this was part of my debugging process. We're stuffing in little print statements here. Okay, so if we determine that that square is playable, we can now move on. So we're going to create this thing called a drawing machine, and it comes from the class pattern. Let's take a look at that. So it's a pretty chunky class. So the class only has one function, which is called create pattern. It gets the ID, and then it is passed in the center of the square. Right? Doesn't need to know what row or column or whatever. Just give me the graphical representation of the center position in which you want me to reveal the patterns. Okay, so I'm not going to go over in great detail about this. It's just a whole bunch of colors, and then I tried to keep it, because my mind was thinking about playing cards, it's kind of what I was going for here. So I created 4 patterns, and each pattern got 3 colors each. So red diamond, black diamond, blue diamond, silver club, pink club, green, neon green club, purple heart, dark green heart, yellow heart, orange spade, light purple spade, green spade, right? So these are all put into a switch statement controlled by the ID, and this ID is the primary key that was explained earlier. Now, now that we have the object created, we can call that create pattern. Now, but before we call it create pattern, we need to identify which pattern is actually hiding underneath that square, which we have been clicked. So the pattern, this is just a very short-term living variable. It only needs to be used in this suite. So the character is set equal to reveal ID's return value. Go into logic, check out return, reveal ID. Reveal ID only needs the row and the column. Again, as explained, I needed to decrement them so that they correspond correctly. Just return whatever's there, because the game board is not loaded with objects, it's just loaded with characters to keep everything nice and simple. Go ahead and check your map, which is here. Which one is it? Oh, it's E, for instance. Okay, we're going to draw that pink club there. So that's what the following line does. So we're going to draw that pattern. and then we're going to flip the display, so we reveal it to the player right away. This portion of the turn, I don't want to call it a full turn because I have identified in my head this turn as being 2 guesses. But this section of the turn, or this guess, is now complete, so we're going to do a little bit of cleanup here, which is we need to increment the guess counter, and then because this was playable and everything was successful, we are going to set our guess to T on that board. So, alright, so here we are, set guess. The number, this represents which guess we are, the pattern, the pattern that was revealed, and its position. So, if the guess was number 1, we're going to set these guess variables here, which let's see, they'll be in the H right here. So here we're just going to keep track of which guess we're talking about, and its position, and its pattern. So these come in handy when we start making comparisons. Now, remember that my guess board is initialized with O's, and then an X in the bottom right. When a guess is made, I set it to T. And T is like an X, but not. So it prevents the square from being played again, which is its main function, to prevent double selection. So you couldn't just hit the same square twice, and then the match function would say, oh, look, hey, they match. So this is that protection for it. And it's not an X, because I don't want it to be confused with a match when at the end of the turn we do a scan of the board to see if the game is over or not. So if the game is not over, well, there will be a T in there if it's not over, and these T's get reset to O's, because they're like, okay, it was a mismatched guess, but we want to make sure that this is playable again, so it gets set to no. This idea, this assignment, doesn't need to be made for the second one, because we're going to immediately check once we leave, hey, do these match or not? If they match, they get X's. If they don't, the first guess will set to a T. This one will always be an O. But the player won't be able to select it again before the guess counter is already reset. So that's why it's omitted in the second case, and why the distinction needed to be additionally reason why. Okay, so we've covered quite a bit. We're coming to the end, thank goodness. And we've just finished covering the events, and more specifically the position of the mouse and what natural functions need to occur once the selection is made. So we've kind of processed the selecting of the square, and now we're going on and we're going to process the results of the turn. So once 2 guesses are made, that's what this guess counter control here on the in the if statement is for. So if we're on our second guess, that means we need to end the turn and see what happened. So let's determine if there was a match first. So game logic goes into this compare guesses. Surprise, surprise. It's very simple. It probably can be done in like 2 lines of code, but this is comparing the character values of guess 1 and guess 2 in the set guess. So right here, guess 1, so it gets a pattern. Guess 2 gets well, they get characters. I'm sorry, char values. They're just named pattern. Okay, so compare guesses. Yeah, let's just say we got a guess right. So we're going to dig deeper into this thing, and we want to register the match. So, and here I have a comment. That means we're modifying the player board, the guess board. Register match. Here we are. So guess board, its value here, and its value here So it's guess one's x and y values, which have already been adjusted here. So they actually represent its position on the 2D array. Mark it as an x. And then its matching pair, do the same thing. Increment the score, obviously, because that's a point. And let's see, so that's if it was a correct guess. If we have an incorrect guess, we want to give the player a moment to reflect on their lousy play. Actually, well, to further memorize the board, 2 seconds. And then we go ahead and cover everything up again. So here these cover variables are coming into play finally. The turn is now officially over. So we reset our guess counter. And we want to check and see if the game or if the board is full, right? So the end turn in this logic, it returns a boolean, and it'll either give us a true or false value, and that board finished is on the very top of the while loop, if you remember, right there. So if we're finished, we're going to ask if we want to play again or not. If we're not finished, we just skip all this nonsense and go ahead and continue off the clock. So before we move on any further, let's take a look at end turn. Here we go. So here it cleans the board of the previous guesses and checks if the board is finished. So I'm kind of smushing two things in once here. This might be kind of a preference thing. I like it when we can kind of confirm what we've done in a function, returning the booleans. I know it's not always practical, but here I thought, hey, we're ending the turn, and we can, since it's very, it's part of the process of checking the board to remove the t's and switch them to zeros. Why not see if the game is done while we're at it? That was my thinking. Okay, so we can now finish the processing of the turn, which is this if statement here. We are ready to draw again. It's set to true. We're going back up here, and we're going through the whole game again. Now, if this while loop is broken, and we break out of it, we're destroying our pointers here. To free up the memory, we return 0. We exit out of the program. Alright, so I need to thank you for your patience. This has been much longer than I originally anticipated. I think for my next video I'm going to work on maybe a structure for these videos so that I can kind of shorten them, make them a little bit more relevant, and perhaps I can just make some inferences in the beginning that we understand that we're going to be going through, kind of like these allegro initializations. I think if nothing new pops up, that I'll just skip them and we can save a lot of time on these videos. But so that's my promise for the next video. There we go. As you can see, 10 seconds has already gone by. Let me restart that. See it pop up. Boom, there we go. So right away the timer starts. I guess I could have put a control in there to wait for the first guess. That would have been much more polite of me. But okay, so I didn't. I'll remember that for next program. The score, 0 out of 12. That's pretty self-explanatory. I really like this font. It looks like an actual scoreboard, little lights. It came out better when I was a little bit larger, but I think it's still pretty neat. So we're going to click the middle square here. Oh, we have an orange spade. Let's look for another one. Here we have a pause, and then they disappear. Okay, we have a yellow heart, and a black diamond. So we can keep on playing. Wow, I've got nothing so far. I feel that this is pretty difficult because a lot of these are very similar. You know, we're just talking about a few color changes. Oh, didn't I just see that? There we go. Yeah, as you can see, the time catches up, so a small pause in time, but it is still running. There was really no way to avoid that. There might be a way, I'm not exactly sure, but I did spend a lot of time thinking about how to, you know, how to smoothen this part out, because this was really choppy for me in the beginning, and I kept running into all these tiny little bugs with it, and I think once I fixed, I think the first dozen, I had taken this good enough for government attitude. As you can see, it kind of pushed over a little bit here, but so yeah. So let me just try and finish this so that you can see the end game. Where was the pink part? Was somewhere up here, wasn't it? Oh, green. Oh, we know that one. It's up here. Oh yeah, and that's a good thing to demonstrate here. So here's a yellow heart. I don't know if you can hear, but I keep clicking on it, and nothing happens. But as soon as I move over, boom. Now it's registering my click. If I click here and on an already selected one, nothing's happening. Boom. Now we get some reaction from the game. Keep clicking this corner here. There we go. Let's get it matched up so I don't have to worry about it anymore. Oh, that guy was, I think, down here. Oh. This heart, I believe, was here. Nope. That was... crap. There we go. Oh. Oh my goodness. There we go. You, there we go. Oh, I know where you are now. And there we go. Okay, that's the game because my screen capture didn't capture one of the more kind of interesting parts that I added to the game. So I'm going to play a game. I'm not going to say much because I'm probably just going to speed this up in post-production. Okay, so here we are. Message box showed up. I can click yes to continue or no to shut the game down. So we click yes here, take note of the time and also the score. Boom, all reset, good to go. Speed through this really quickly just to show you the no action. Okay, here we are. Let's hit no, and boom, program is closed. Great. Well, I just want to thank you for bearing with me. I understand this video was long. As I previously mentioned, I will work on that and come up with a better plan of attack. But again, I thank you for watching, and I will see you for assignment number 3.